Good night, everyone. Geotechnical Engineering, Part A, Soil Mechanics, Chapter 12, Shear Strength of Soil. Let's review the failure mechanism. At the moment of failure, we want to calculate shear strength by formula approach. Let's see how we can approach this problem. So at the moment of failure of a soil sample, which happen to handle a sigma normal stress and shear stress, we have two we can study two cases like formula approach and also geometric approach. Let's In this video we want to talk about the formula approach, and then in the next video we'll talk about the geometric approach to calculate the estimate the mechanism of failure soil sample due to shear. So formula, it just gives us, if you remember from previous part, it just gives us the resisting and also applied stresses to the soil. So the resisting was tau is equal to C plus sigma times tangent of phi, and the applied to the soil consists of two parts, which is a sigma is equal to sigma major plus sigma minor over 2 plus major minus minor over 2 times cosine of 2 theta. Theta here is just 45 plus phi over 2. We'll talk about theta, which is the angle of failure, with respect to the major stress, which is sigma 1, to the plane of major stress. And also we'll talk about them in detail later on. And the sigma, which is a applied shear to the soil, which is going to tear apart soil, that is major minus minor 2 times sine of 2 theta, which is this angle. We had reviewed this formula in previous video in soil, and now let's see what is happening at the moment of failure. At the moment of failure, we'll have a resisting shear, which is this one is a tau the failure, but this is resisting, or you can call it also tau resist. You can call it tau resist or tau F resist, which is C plus sigma times tangent of phi. And the second one is the applied one, which is consists of these two parts. And at the moment of failure, you can convert all this sigma with change it to sigma major failure, sigma major failure, minor failure. So the theta is theta failure. So all things move to failure of failure. And at the failure, we do know that the resist is equal to applied. Then applied is going to increase and increase and increase, all of a sudden reach to the resisting. As soon as they are equal to each other, that's the threshold of failure. We call that then resist is equal to applied in terms of resisting shear, or applied shear is almost going to be equal to resisting shear. That's the moment or threshold of failure. And also tau F is also 45 plus phi over 2 of friction of soil over 2 plus 45 is theta F. So if you remember, we already told not all the applied are bad, and by bad it means destructive. So if you remember a soil sample, which this is a sigma applied to, this is the shear tau failure. There is a tau resistant of soil. And if you remember, we already talked in previous video that there is a sigma, which this sigma is also of the nature of applied forces, like what you can see here. but all the applied forces are not bad. So it just says this is a kind of a stabilizer force. It just making the soil more condensed, and it's a kind of help to the soil. It's not going to shear the soil apart. So one can say we can call this one like a stabilizing force. This is the nature of applied force, but this is a stabilizing, and only tau F is a destructive force. So we can again jot down our equation, and that's an important understanding of this mechanism. Tau applied is equal to tau resistant, so destructive is equal to resisting shear, destructive shear is equal to resisting shear, and resisting shear is nothing but C plus sigma times tangent of theta F. I think that's tangent of, that should be tangent of phi. Let's see how that goes. Yes, that's tangent of phi. Then in the equation will will reach to that part. So as soon as we have tau failure equal tau resistance, which is C plus sigma times tangent of phi, yes, that's internal field. It just says sigma major failure minus minor failure average of m times sine of 2 times theta f is equal to C plus average of these two plus a major failure minus minor failure 2 times cosine of 45 plus phi over times tangent of phi, which is here. If you want to see how that goes, this is nothing but tau failure, and this is nothing but tau f, or resisting tau fr, tau r. When these two are equal to each other, if you equalize these two equations, it just gives you, and it just manipulating and rearrange your equation, it just gives you sigma 1 failure is equal, you can write the major major stress based off minor one in the time of at the moment of failure. That's nothing but sigma major at the failure time is equal to sigma minor times tangent squared 45 plus phi over 2 plus 2 times cohesion of the soil times tangent. Definitely if your soil is sand, this term goes, there is no C, and you don't have this term. And if your soil is clay, then definitely you have some kind of C, like 2.5, 1.5. There is C, so you have this term. That's just in case. And also you can jot down, if you jot down the equation based off sigma minor, based off sigma major, have the same kind of formula, similar kind of formula, but this time sigma minor failure is equal to sigma major failure tangent squared, this time 45 minus phi over 2, and this time plus minus 2 times cohesion of soil times tangent of 45, this time minus phi over 2. And the interesting part is these are the two well-known equation in terms of ranking passive and active theory, which we'll talk about them in next videos. In next video, we'll talk about the same kind of derivation of formula, but in geometric form, and then we'll move on to a ranking passive and active theory, which is very famous in observing overtopping and sliding concept. Thank you. See you in next videos.